Hello guys, welcome to topic 1. If I had to describe this subject over the next 12 weeks, it's about inferential statistics. So that's about inferring something about the population based on some sort of a sample. So over the next 12 weeks, we'll be looking at a few, or I guess various quantitative methods to infer something about the population. In this week's topic, we're going to be looking at our first basic method, and that is using graphs. So the best way to explain that is, I guess, let's go straight to an example. So let's say we've got a bank manager who's interested in maybe providing some loans to students. And so he's collected some data regarding student income. So for example, let's say we've got one student here that's earning $2,000, or another student here that's earning $10,000, or another student here that earns about $12,000. So we've got about 31 data of student income. So as it is, it's pretty hard to maybe gain some sort of information from this data set. So one of the easiest things we could do is actually order it. So I'm just going to highlight these numbers, and in Excel you can order it pretty quickly. I'm just going to go to sort, and we're just going to sort maybe from smallest to largest. So through this step, we can actually gain 3 key information. Right? The first information might be, okay, the lowest income is $2,000. And the highest income is $22,000. And then we can also see some sort of variability of student income. So remember how I was talking about inferring something about the population based on a sample. So assuming this sample that we've just collected is a good approximation of that population, we can say, okay, generally student income, the lowest would be $2,000, the highest would be $22,000. And generally we have some sort of, I guess, idea on the range of incomes available. Okay. In terms of employing some graphs to actually maybe flush out further stories from this data set, there's various graphs available. And today we'll just be going to be concentrating on the histogram. Before we actually employ the histogram, however, it's useful to do what's known as some sort of frequency distribution or frequency table. To do that, though, we're going to be following a couple of key steps. So first thing is we're going to be calculating the range. So the range is simply the highest number minus the lowest number. So that's our range. Second thing is we're going to be calculating these bins. So bins are basically boxes in which we're going to be placing some numbers in. So bins should usually be in the range between 5, anywhere from 5 to, let's say, 15. So it's quite subjective what number you want to choose here. I'm just going to choose a number 6. So there's 6. And so the width of each bin is about 3.33, but usually we're going to be rounding these bins off to the highest number. And so let's say each bin would have a width of 4. So how do these calculations actually make sense? Well, let's use this number 4 as our first bin. So our width of each bin is 4. So my first bin is going to contain numbers from 0 to 4. So with this curly bracket usually means, or it does mean not including 0. This square bracket means including 4. So I'm going to put all numbers between 0 and 4 from this data set into this bin. So for example, how many numbers are from 0 to 4? We can say it seems to be, there's three numbers that is between 0 and 4. And so under this frequency column, I can put the number 3. And so for the next bin, you'll notice that it also has a width of 4, so 4 to 8. And the next bin also a width of 4, and it goes all the way to our last bin. So remember that we chose to have 6 bins here, and there should be 6 bins there. Okay, so similarly, for example, I'm going to put all numbers between 4 and 8 into this bin. So how many numbers are between 4 and 8? So let's have a look. Including 8, it seems to be 5 numbers between 4 and 8, and there's my frequency of 5. So we can keep going with that and fill in each of these bins. So in theory, all these frequencies should add up to the number of numbers we have here. And recall we had about 31 numbers. So the sum of all these numbers should be 31. Now with these other columns, I'll just talk about them briefly. The midpoint is basically the middle point of each bin. So the middle number between 0 and 4 is 2, or the middle number between 4 and 8 is 6. The percentage represents the relative frequency. So for example, 3 out of the total 31 represents 9.7, or 5 out of the total 31 represents 16.1%. Cumulative frequency is basically a continuous count of your frequency. So it starts at 3, and then the next number here continues that count. So it'll be 3 plus 5 would be 8. Or here, it will be 8 plus 8 would be 16, and so on and so on. So it continuously counts the frequency. And the cumulative percentage is a similar calculation where it adds up continuously your percentages. So it starts at 9.7, and the next one will be 9.7 plus 16.1. And for example, 25.8 plus 25.8 is 51.6. Okay, so each of these would be useful to construct the various graphs that we'll explore in topic 1. But in today's video, we're just going to be concentrating on the histogram. So the histogram is, I've already constructed one somewhere down here. The histogram is quite simple. On the y-axis represents your frequency, which we now have data to construct. And on your x-axis, we have these classes. Okay, so the actual mechanics of constructing the histogram is quite easy once you have the bins. But I'm not going to really focus on that for the time being. I just want to focus on the interpretation. So, for example, graphing this, we can actually maybe gain a few more stories here regarding our data. We can see, okay, so for example, if I was the pack manager, I might observe that it seems that most students around here earn an income between $8,000 to $16,000. Very little students earn in this higher bracket of 20 to 24,000, and there's a fair portion. I mean, not that much, but there's a fair portion that's earning between 0 and 4. Generally, it might be useful to comment about the shape of this distribution. So it kind of does look like a bell shape, right? Which might refer to something like a normal distribution, and we'll talk about that word in the following weeks. But for now, just appreciate that it does seem to follow some sort of bell shape where numbers are clustered in the middle and trails off at the end. From that example, you may notice that we started off with a data set that on its own didn't really provide any information by doing some simple things like ordering it, and then we could find the minimum and the highest income in the range. And maybe by doing a simple graph, let's say the histogram, we could really flush out some important information. In the next following weeks, we'll be looking at various, or I guess many quantitative methods to actually flush out some sort of story to infer about the population. Even doing very simple things can get us very useful information. And that's it. I'll see you guys in the following video.